I want to share a little bit with you tonight about my research in Antarctica. I've spent 35 years exploring and diving in the waters of this amazing continent, and it's just been absolutely a spectacular thing to do, an honor to work there, and I just can never wait to get back. I'm hoping to be leading a cruise back, a climate change themed cruise this coming December. And after I speak tonight, if you're interested and want to come down and chat about that or ask questions about what it's like to live and work in this very remote part of the world, I've also got some copies of my book, A Naturalist Goes Fishing, that I can sign for you if you'd like to purchase a copy. There is a chapter in there, by the way, on Antarctic fish and their conservation. So I've been working here for a very long time. I never get tired going back to Antarctica. And I want to just share with you now, if I can get this to... I will never forget the first time I put on a dry suit, a suit designed to keep you warm, so to speak, in minus 1.8 degree water, and drop below that ice, just like you saw in the film. The seafloor is covered with life as far as you can see. It's one of the richest marine ecosystems anywhere on our planet. And it was such an honor to get to work there and study these amazing organisms that cover the seafloor. So I want to tell you a little bit about climate change and how it's affecting the continent. And I also want to talk about some of the different types of research that my group has been doing down there these many years. So in the next slide, we know that this system has been very rapidly warming. The cover of Nature magazine, one of the top science journals in the world, back here in 2009, was documenting the warming regions of our Earth. And Antarctica caught their attention because the eastern portion of Antarctica, while it's not warming as rapidly, the western portion is very rapidly warming. And the Antarctic Peninsula, where I've been working most recently. So that orange area you see are areas of warming. This continent is amazing. It's the size of India and China combined. So we're really talking about a massive continent surrounded by ice shelves and sea ice. My home, away from home, the last 20 years has been where that arrow is pointing, on a little island called Anvers Island, about halfway down the Antarctic Peninsula. And it's been warming very rapidly. We know because there's a station nearby that's been recording air temperatures for about 60 years. And if you plot those air temperatures, it's increased about 10 degrees Fahrenheit, the midwinter air temperatures over those 60 years. So that's very, very rapid. What is happening as a result of that is we're seeing changes in the ice. And we saw that in the movie. The glacier behind the station where I work, the Mar Glacier, when I first showed up at the station 20 years ago, about once a week, I'd hear this huge crash, and you'd leap up and run down the hall to look into the bay, and you'd see big chunks of ice falling in the water from the Mar Glacier. And when I was down about a year and a half ago, this was happening every day, many times. So you can see up and down the Antarctic Peninsula, about 87% of the glaciers are very rapidly retreating. Now, I could talk quite a bit about the ice, but what I really want to focus on is the marine life that I've been studying as a marine ecologist. And probably the most poignant story of climate change I can tell you about that's affecting the western Antarctic Peninsula is the story of the Adelie penguin. And Bill Fraser, who's in the very back of this photo up in the left, as a graduate student about 40 years ago arrived near Palmer Station, and for part of his doctoral work, he tagged every single pair of 16,000 Adelie penguins. Now that's what you call a dissertation. He came back every year since, and he's been documenting this population of Adelie penguins near the station. And I just want to show you what he's found. The purple line is for the Adelie penguin up in the top left picture in the corner there. And what he's found is that over this period of time, since he showed up in the mid-70s, about 90% of those penguins have disappeared. They haven't moved, but they've really just disappeared. At the same time, the penguin in the center picture, the Gen 2, and the chin strap to the right have appeared. These are warm weather penguins that are showing up because the Antarctic Peninsula is warming very rapidly. And there's smaller numbers of them, but there are now about 1,000 of the gentoos that are nesting here. So some are showing up, the adelies are disappearing. Well, why are the adelies disappearing? It's interesting. There's several different reasons that are hypothesized. One is that, ironically, as the air is warming on the peninsula, it's getting more humid. And the more humidity in the air, the more heavy the rainfall. In this case, snowfall. So they're getting heavier snows later in the season, and the penguins arrive, lay their eggs, and sadly, the eggs get covered with snow and don't survive when that melt occurs. The other thing that's affecting the Adelie penguin is the sea ice that doubles the size of Antarctica during the winter and then recedes in the summer. The Adelie loves the sea ice. It's a sea ice dependent species because it slides across the ice on its belly, and it can go a long distance out to the ice edge and then forage on krill that it loves to eat. And it doesn't use much energy to do that because it's sliding on the ice. Now, because the sea ice is disappearing, the penguins are having to swim offshore and use a lot of energy. And Dr. Fraser thinks that that's another contributing factor to the problems that they're having. Now, problems aside, there was an amazing discovery recently in 2018 of an island just around the northern tip of the peninsula where it's much colder, over on the eastern side, where a very large colony of Adelie penguins was discovered, over 1 million. And this is really good because it means that we sort of have this surplus of Adelies. And while we're losing them to the effects of climate change, it gives us a little more time to try and do something about that effect of climate change. Krill, of course, are also subject to the effects of climate change. So far, they're doing okay, but there are areas along the peninsula where these little shrimp-like animals that form the base of the food web are receding in numbers. That's a concern if you're a baleen whale. And there are some thoughts that these krill depletions could affect whales. On the other hand, as you saw in the film, the whale populations along the peninsula are just fantastic right now. And I've talked to the whale biologists. They think what's happening is that they're finally recovering from the very heavy hunting that went on. And they're reaching numbers now where they're just exploding in numbers. I can remember a single afternoon on the cruise ship one day counting over 50 of these humpback whales off the ship. The other organisms that are potentially affected by climate change really are many, but I want to highlight a few of those that are really spectacular animals. The leopard seal that you saw in the film is a seal that we have to deal with regularly as we scuba dive around Palmer Station and also over at McMurdo. If we see a if we see a leopard seal while we're diving, we have to get out of the water very quickly because they are aggressive and they can approach divers and give them a good scare. I did have an encounter once with a leopard seal. One of my first dives at McMurdo Station, we were out at the ice edge, and my dive buddy and I and some others were getting into our dive gear, and a leopard seal came out of the water and just looked at us with these beady yellow eyes, and then slipped back into the water real quickly, and we looked at each other and said, "I don't think we should dive here." Well, about an hour went by, and we talked about it, and we decided to just take our gear, and it was a lot of work, but we carried the gear along the edge of the ice quite a distance, and it had been a couple hours now. We hadn't seen the seal. So we decided we're going to dive. We got suited up, and my dive buddy, whose name was Ron, Ron was sitting on the ice with his feet dangling in the water, reaching for his mask. So he was 15 seconds from going in the water. And all of a sudden, that leopard seal, I'm sure it's the one that we had seen, came right up between Ron's legs and looked him right in the eye. Ron did 2.5 backflips with 50 pounds of gear on his back because that leopard seal was looking him right in the eye. We did not dive there that day. I just wanted to say, though, one thing about the leopard seals is that they've never been seen breeding or giving birth anywhere but on the sea ice. So there's some interest, when the sea ice recedes completely, are the leopard seals going to go to shore and give birth on land for the first time, or will they try to follow the ice to the south? Nobody knows the answer. Now, one of the most amazing things that I've been involved in studying in terms of climate change is how there are some invasive species showing up in Antarctica now. And I'll set the stage here. You're looking at the seafloor of Antarctica. It's a very ancient seafloor community that goes back probably tens of millions of years when Antarctica separated from South America. This is an ecosystem where there's some organisms that just aren't present. There's no sharks in Antarctica. You don't have to worry about sharks when you're diving. There's nothing with a claw. There's no crabs, there's no lobsters, there's no fish with crushing jaws. So if you are a clam, you don't have to worry about being crushed because there's nothing that's going to pick you up and eat you. Well, you can imagine the shock of my colleague Sven Thatchy, who was flying a submarine about 1,100 meters below the ship he was on. It was a remotely operated submarine. And for the first time in recorded science, he discovered king crabs moving up the slope towards the Antarctic shelf. And while we knew that king crabs had lived in the deep sea around Antarctica for a very long time, they were thought to be kept out of the Antarctic waters because it actually gets colder as you go up towards Antarctica, and king crabs in general don't like cold. They physiologically don't tolerate cold. They act like they're drunk, they fall over, they just can't cope with cold. So what this meant was that people started poking around, and sure enough, a huge population of king crabs was found in a very deep canyon below the Antarctic shelf, fortunately. And we have had a number of grants from the National Science Foundation to go to Antarctica with this ship and pull a submarine up the Antarctic slope, taking pictures every few seconds and documenting the king crab populations. Hundreds of thousands of images had to be analyzed, and when you're a scientist and you have to analyze that much data, you use a very important instrument called the graduate student. And so we were able to, after looking at all this data, the king crabs are on the slope in the millions, but they have not reached the shelf. So that community is still protected from crushing predators, but we're concerned about following that into the future. These are beautiful little sea butterflies, tiny little shelled snails that swim in the water. There are as many of these in the ocean as there are stars in our sky. Their shells, made of aragonite, are important in the global carbon cycle, if you can imagine. And we know now that you can go to the Southern Ocean, and ocean acidification, the process of carbon dioxide coming into the world's oceans and making them a little more acidic, is already beginning to deteriorate the shells of these beautiful little animals. And so Antarctica is a place where people are studying that. So what's happened over this period of time that's relatively short? We've gone from the Antarctic Peninsula communities looking like this. Very predictable sea ice, large populations of Adelie penguins, lots of krill, a rich seafloor community, lots of seaweeds, and this is all being fed by this ACC, the Antarctic Circumpolar Current. It's a very rich water, lots of nutrients. And then here we are, probably by mid-century, the sea ice will be gone, the Adelie will be gone, the Gentoo and the chinstrap will have moved in, we won't have as many krill, we might have king crabs. This is a remarkable change. And you're probably thinking to yourself, well, come on, biological communities change all the time, don't they? Sure they do, but what's happening under climate change is that these changes are very rapid. This is happening in a few decades, whereas in the past it might have happened over thousands of years. So this is a very fundamental different thing, and we're finding that some organisms are not going to be able to survive such rapid changes. So that's something you need to remember about climate change. It's not that things don't change, they always change, but it's how fast they're changing that's a concern. So why in the world would anybody care if changes are happening to the marine life of Antarctica? And fortunately, I think I have a pretty practical answer. And that relates to the work that some of my research is in, an area called chemical ecology, where we study toxic chemicals that are produced by sponges and corals and different kinds of Antarctic marine life. And anytime we find a toxic chemical and name it, we send it off to be screened against cancer and AIDS and cystic fibrosis and different kinds of infectious diseases. So it's really neat. We do basic ecology, but we also are doing applied medical studies. And I'm just going to very quickly tell you we've had some success in this area over the past few decades. One of the most exciting stories was an Antarctic tunicate. It looks kind of like a baseball, an orange baseball, and it has a chemical in it that we named after the station. We called it palmerolide. And this organism, Sinoica madarium, makes this palmerolide probably to protect itself from things eating it. But at the same time, the National Cancer Institute found out by screening this compound that it's very active against one of 22 different types of human cancers, melanoma skin cancer. And they actually worked on the chemical, and it's possible down the road that we could have a chemical from an Antarctic tunicate that's used for a new way of fighting melanoma skin cancer, a disease that we really don't have much of an arsenal of drugs to use. The other really exciting discovery was more recent. This is a sponge called Dendrilla membranosa, right there in the center, just to the left of the starfish. And this sponge has a compound in it, darwinolide. Darwinolide is very potent against MRSA, the bacteria that we all have heard about you can get in the hospital that causes a lot of problems because it's not reactive to antibiotics. And so there was a lot of interest in this compound for the potential to fight MRSA. So my point here is that you know that this is a very rich marine community that's very ancient. There's been a lot of evolution of different chemicals. So we've just touched the tip of the iceberg, excuse the pun, in terms of drug discovery. And why would we squander that to climate change? We need to protect those organisms because they could be important to us. So, is it gloom? Well, I always like to provide hope in the world of climate change and what we're doing to our planet. And Antarctica has a wonderful story of hope. And that is that in 1985, there was a couple of technicians sitting at their desk at a station in Antarctica that sent the data back to their professor in England and said, "You're not going to believe these data." And you know what he did? He said, I don't believe the data, and I'm going to send you back next year with a new spectrophotometer. You're going to measure it again. I just can't believe it. And sure enough, they found a massive hole in the ozone, that very important layer of the atmosphere that protects us from ultraviolet radiation. They found this hole, and it was a big deal. They published a paper in Nature, maybe one of the most important scientific papers of the 20th century. This is what protects us. This changes the climate. This had huge implications. And what was so remarkable to me was that the compounds that were destroying our atmosphere, the chlorofluorocarbons, the refrigerants, well, we were able to control their production. And the way it happened is 2 years after the discovery, in 1987, 20 countries sat down around a table in Montreal, Canada, and ratified the Montreal Protocol, probably the most successful global treaty of all time. And they came up with a rule. You have to produce refrigerants that don't destroy the ozone. And so innovation went to work. Countries figured out how to do it. Rich countries helped the poor to establish the technology. And today, Susan Solomon, a good friend of mine who is an atmospheric chemist at MIT, tells me that the hole in our atmosphere over Antarctica has stopped growing. And instead of it closing in 100 years, it may close by 50 years. So it's a wonderful example of countries coming together globally addressing an issue that affects our planet's climate, that affects radiation, cancer, and many other things. So I just want to take a last minute to tell you a little bit about me, a scientist who's decided it's really important to talk to people around the world about climate change and to bring it to their attention. One of the things I was told early on is if you're going to talk to people, you need to have a book. You need to have a book everybody can read that tells the story of your coming to realize what a big deal climate change is from your work in Antarctica. So I decided I'd learn about writing a book. First thing I found out is to write a book, you have to have something called a literary agent. And then I found out to have a literary agent, you have to have a book. So that was kind of tricky, and I managed to make it happen because of my friendship with E.O. Wilson, a wonderful, brilliant scientist, perhaps the greatest living scientist we have now on Earth. And he was able to find me a literary agent. I published Lost Antarctica. I didn't know what that book would do. And one of the things that was so neat was that the doors had opened for me. I got a phone call from the director of the E.O. Wilson Foundation, and she said, "Jim, the chapter on the Adelie penguin, we want to make a film. We want to make a 3-minute film that's going to go in aquariums and museums, and it's going to tell this poignant story." And I love the prose, and I thought, okay, she's trying to get me to say something here. She wants me to ask if I can narrate from my book. And so I said, I'd be happy to narrate. And she said, no. She said, we'll have Harrison do it. And I said, Harrison? Who's Harrison? She said, Harrison Ford, of course. He's on our committees. And I said, okay. So you can actually go to YouTube and you can type in ghost rookeries and you can listen to Harrison Ford reading from my chapter about the Adelie penguin. He does a wonderful job. And what an honor for me. The other things that I've been doing to try to communicate climate change to people is take advantage of my knowledge of Antarctica. So I've been leading for the past 11 years now a cruise, one time a year, to Antarctica for Abercrombie and Kent. So if any of you are interested in finding out the details, come up after and I'll talk to you about that. It's a wonderful way to turn people into ambassadors for Antarctica, to teach them about climate change. And I think it's a really, really successful enterprise. The other thing I've been doing is to look at how faith is important in communicating climate change. And I've held workshops such as this one here, where I talked about the science of climate change, its impacts on the environment, and an Episcopalian priest spoke about how, the stewardship of the earth and how important it is to look at it in that biblical context. And so this is something that I'm doing more and more now. And then I was asked by the National Nature Conservancy to be one of the faces of the Can We Talk Climate campaign, because as Americans, we're not real good about talking about climate change. So what you do is you pledge. You make a pledge for no money. I love pledges with no money. That in a week's time, you will talk to one other person about climate change, and then the website gives you all sorts of great ideas about how to find common ground with people to talk about climate change. Maybe you should talk about how soon their tomatoes are coming in. That's very unusual. Ways to get the dialogue going. And then I'll end with this note. I was extremely honored several years ago to be invited up to Manhattan to be part of the Explorers Club annual dinner because I was receiving an award for my research and my educational outreach in Antarctica. I was equally honored to find out that the 8 of the living Apollo astronauts were going to be on the stage with me that night. And it was absolutely a stunning evening. We actually had dinner with one of the 3 astronauts, the one Collins, who circled the moon while Buzz and Neil Armstrong landed. Buzz was at the dinner table next to us. You can see him here in the picture. He's very flamboyant. He likes to wear funny clothes and stuff, but he's sitting there towards the end of that line. To the right of Buzz is Schweibert. And astronaut Schweibert was one of the pilots. But he was the most poignant speaker of the evening. They each told a story about something funny that had happened up in space, or an observation that they hadn't shared with the world. One of them recounted a story where his wedding ring came off and floated out the door of the capsule, and somebody grabbed it at the last second. And I mean, just wonderful things. So Schweibert got up and stood up and looked down the row. He was the last astronaut to speak. And he looked out over the 1,500 people in the audience, and everybody sort of hushed. And he said, you know, and he looked down at the other astronauts, all of us here on this stage, the astronauts, have been up in space. And we have looked back on this planet. And one of the things that strikes you when you look at the Earth from space is the fact that it's incredibly fragile. That biosphere, that little layer of life around this, the very circumference of the Earth is very thin and delicate. And I'm thinking, as a scientist, you know, when you do an experiment, you have something called a sample size, and your sample size is usually 10 when you fool with something. And here we have a sample size of 1, and so we have to take care of this. And with that, I'll end, and I would invite you up if you have questions, and I'd be happy to sign a book for you too. Thank you.